I'm Mark Kavanaugh for Cavi Coaches, and today I'm going to coach you up on free fall and kinematics. Today we're going to talk about solving problems in free fall. What is free fall? Free fall is defined as an object that falls or is launched as it moves through the air unimpeded, meaning that there is no air resistance. Examples of that would be just a ball falling to the earth, or if we launch that ball up into the air and it returns back down. So we're going to look at a situation of two objects being dropped from the same height. These objects are going to accelerate at the same rate, even though they have different masses. Here's a textbook and a marker falling through the air towards the floor, and you can see at each frame they're next to each other and hit the floor at the exact same time. Now, at the same distance, the same initial velocity, that means they're going to have the same acceleration, which is the rate of 9.8 meters per second squared. This is called the acceleration due to gravity. All objects fall to the Earth with an acceleration of 9.8 meters per second squared, regardless of their mass. This number is so important in physics that it gets its own symbol, lowercase g. Lowercase g represents the acceleration due to gravity. Looking at an example problem, we have a student tossing a rock into the air. We recognize this with an initial velocity that it's going to be a kinematic question. So we're going to draw a diagram as well as list the 6 variables, putting the dashes with the variables that are missing from each kinematic equation. We define up as positive. With up being positive, that means this speed of 20 meters per second is going to be a positive 20 meter per second velocity. And we know that we're looking for the highest point. Information we know at the highest point is that's where it's switching direction. So thinking of a velocity time graph, that's where it would cross the axis, meaning that the velocity is 0 meters per second at the highest point. We're going to define the bottom of the flight path to be 0, where the student launches the rock. That's a position of 0. We could define 0 anywhere, but it's the lowest point for the rock. So we're going to define that as 0. That's our initial position. The rock is in free fall, which means that the acceleration is negative g. Why negative? Well, we defined our velocity as positive, and with it moving upward, it's going to slow down. And slowing down means that the acceleration and velocity have opposite signs. So our acceleration is negative 9.8 meters per second squared. Now, the question that's being asked is, how long did it take for the rock to reach the highest point? We're looking for time. So the variable that we don't know is the final position. Final position means that not knowing that, we're going to use our first kinematic equation. We'll rearrange that equation and solve for time. Plugging our numbers in, we can see that we have negative 20 meters per second divided by negative 9.8 meters per second squared. Simplifying the units, we see that we have 1 over inverse seconds, with everything canceling out but 1 of the seconds, which gives us a value of 2.04 seconds. If you were asked to figure out the total flight time of the rock, all you would need to do is to double that time. It would be the same process. You would just take and figure out how much time it took to get to the top and double that to reach the bottom again. Looking at another example problem, we're going to use the same diagram, same situation. At this point, we're just going to start the problem over and without knowing time. So we know that it's a kinematic problem, so we're going to list our 6 variables. The acceleration due to gravity is negative g. Again, we assume up is positive. Tossing the ball in the air means that it has a negative acceleration. 20 meters per second, that's our initial velocity upward, so positive 20. So acceleration and velocity have opposite signs. What height did it reach? Well, the maximum height, what do we know at the maximum height, is that the velocity is 0, again, where it's switching directions. The question that is being asked is, what height did the rock reach? So we're going to assume the bottom of the flight path is 0 again. And what height it reached is the question. So we're going to put a question mark for our final position. And time is the variable that we don't know. The third dash means we're going to use the third kinematic equation, the Vx squared equation. Crossing out everything that is 0 in our equation and rearranging that, we get 0 is equal to Vx squared plus 2ax. And we solve for x, we get this equation 0 minus negative Vx naught squared is going to give us negative Vx naught. Plugging our numbers in, we can see that the units are going to cancel out. So seconds squared are going to cancel out with seconds because they're squared at the top. And the meters are going to cancel out on the bottom with one of the meters on the top. So we're still squaring the meters as well. So we're going to be left with meters, which is a unit for position, which is what we want. So when we do our calculations, x is equal to 20.41 meters. That means the rock is going to reach the highest point of 20.41. Looking at a third example, same situation. Again, we're going to take into account that we know none of the previous information. Knowing that this is a kinematic problem, we're going to list our 6 variables again. We're going to put the dashes in front, and the rock being tossed into the air means that the acceleration is negative g. Again, negative because we're assuming that up is positive. This 20 meters per second is a positive velocity upward. Now we're asked for the entire flight time in this question. So we're going to define the bottom of the flight as 0 again. That's our initial position is 0. It asks for when the rock returns to the same location. Well, the same location means that final position is also 0. The question being asked is what speed, so I'm looking for the final velocity in this case. Not knowing time means that we're going to use the third kinematic equation again, Vx squared equation. Crossing out everything that we know that is 0, which is the initial and final positions, plugging numbers in leaves us with this equation. Well, we know that anything times 0 is 0, so that's going to give us Vx squared is equal to Vx naught squared. And then taking the square root of both sides, we get Vx is equal to Vx naught. So the final speed is going to equal the initial speed. So the final speed velocity is 20 meters per second. If we were to make this a velocity, we'd have to add a negative sign. The third kinematic equation only gives us the absolute value since both velocities are squared. So we would have to define negative. This is using free fall motion. Important information is that the acceleration due to gravity is your acceleration as soon as you see that an object is tossed or thrown into the air. I hope this was helpful. I hope you have a great day and an even better tomorrow.
If you found this video helpful, don't forget to click the like button down below and subscribe to my channel, Cavi Coaches, and follow me on Instagram and Twitter @Cavi Coaches.